now that Swift is open source, Apple has given us opened us up to way those more possibilities. You can now take your existing knowledge, code, and apply them to web application development. So I'm going to show you how you can reuse existing skills to build and apply your first web application in Swift. So before we dive into the subject, let me quickly introduce myself. My name is Kyle, and I'm currently working at a company called Apri. The IRC client was just a side project, so full-time work at Apri. We are an API design platform. So in the past, I've built dozens of iOS applications outside of work, and I've also contributed to many open source Swift libraries. So in the Objective-C and Swift scene, I'm mostly known for lots of the open source projects I've contributed to. According to CocoaPods, I've touched 1/3 of 1 million applications that use CocoaPods itself, with over 15 million downloads. So I'm really curious on how many of you have built web services before in the past, such as APIs. So if anyone has experience, please all right, interesting. So quite a lot of you, more than I expected, at Mobile Conference have actually already have experience at API development or web service development. So for those who are not too familiar with the subject, let's just take a deep thought about what actually is a web service. So a web service is a service that's offered over the World Wide Web. HTTP is one of the popular communication protocols used in this. It's supported by all the browsers. Today I'm just going to be talking about HTTP, because I'm sure not many of you will be interested in using other protocols, such as IRC. So I'm going to be talking about both building web applications and web services for APIs in Swift that you could communicate to with your own application. So in the past, there's many languages you can use for web development. Quite often people use Ruby, Python, PHP, or Java, and they have some quite popular choices. So you're going to be faced with this question, well, since we already know how we're doing this, why don't we just do it in existing languages? Why would you use Swift on a server? So I think there are a couple of good reasons why you might want to do this. So let's tackle them. So I personally think the biggest reason is Swift itself. It's a beautiful language that brings some really new concepts or existing concepts and reapplies them to the new world. So traditional web applications are built in scripting languages like PHP, Ruby, and Python, with the exception of Java. Swift brings us the style of Swift scripting languages and an incredible performance along with the powerful type system. So why do many use scripting languages for the web? Well, I think there are many reasons for this. It's been used for a long time, so it's very easy to deploy scripting languages on the web. And most say it's easier to build websites in scripting languages. And it's common to think scripting languages allow higher developer efficiency, and there's a kind of a trade-off between raw performance, which is usually acceptable in web applications. Swift was designed to give us high productivity and high performance from the start. Here you can see a slide from Apple's State of Union in 2014, where they announced Swift itself at the conference. They've compared Swift against other popular scripting languages that are used on the web, and you can see that it's kind of aligned in developer productivity, but you also get the high performance, and they actually said that it's higher performance than Objective-C back then. That was 2 years ago. Another important benefit that all of you here, I assume, would be able to utilize is that you can share code between both your back end and your front end. So your iOS app would be in the front end in this case. You might be able to share models and other related code back and forth. And there are also efforts being made to port Swift to Android. So eventually, you might even be able to share code between 2 mobile platforms and your back end. And what's great is that many already have a deep understanding of Swift itself. You deeply understand how the language works, which allows you to use this existing knowledge and skills that you've utilized, collected over the many years, to build web applications, which you haven't been able to do in the past without you picking up a brand new language, unless you already had experience to that. And Foundation will be supported on Linux Free when it comes out, which even means that you can take your existing knowledge of Foundation and all of the APIs you're already familiar with using iOS applications and take them to web development. And at the moment, it's kind of a bit early to talk about performance because there isn't really a stable version of Swift you can use. There is 2.2, but it misses many things you probably want for web development. But it's clear that Swift has a high potential in performance especially compared to scripting languages. I've done some small benchmarking with a simple Hello World application I wrote using my own HTTP server called Curacao in Swift, and I've also compared it against like similar working HTTP servers in both Ruby and Python. And you can see that my server is capable of handling 45% more requests than Ruby's Unicorn, which says something considering this is a pre-release of a language, at least for version 3.0. And I'd also like to mention that IBM seem to be heavily interested in using Swift on server, outside of their mobile stuff. They've also started supporting it in their new platform they're using for web development called Bluemix. And they've also launched their own web application framework called Kitura. So now we've covered why you might want to do this, let's take a little look on how you would go about this. So I'm going to show you a short example of perhaps some code you might find in an iOS application. And we're going to show you how you can just rewrap it into like a web application. So I want to point out this example is just purely for demonstration purposes. It might not necessarily make sense to use this specific example in real world. So at the root, I've built a simple function called function for date. It takes an NSDate, which is included in Foundation, and it returns a string, which is basically a format date. And internally, it uses NSDate formatter. NSDate format is part of Foundation, which is available on Linux at the moment. So we can use this function within our mobile application. Inside sort of view did load, and you're all familiar with inside a view controller, we can perhaps just use this function to set our formatted date into a button title. I'm sure you're all familiar with this kind of stuff. And without much additional work, we can wrap this existing function into a web service directly. Here I've built a small web application which just handles every GET request and returns just the string itself. So we can use the Swift package manager to build it using Swift build. And it will download the web application like framework I was using, and then it will build everything together into a command line tool, and then the next line I just run it. And once I've run it, it's now listening for the internet. So that short example is now a HTTP server. So when we hit a request to this server, like a GET request, it's just going to return today's date, because we did it today, as we formatted. So Ben Sherman from NS Screencast has actually built something similar to what I've shown today. He's gone kind of like many steps above that in a website called nsdateformatter.com. Now what this does is it allows you to put in your own format and your own date in the ISO format, and it will just show you how that will be shown. So it's great for like playing around with date formatters. And it also has a bunch of examples and like guides on how to do it, which is kind of cool. So he's built this entirely in Swift and it's open source. You can all check it out for reference. So we've had a little quick example. Now let's take a little deeper look at this. So where can we build, where to begin? There are many steps in building web applications, which I'm not too sure what you're familiar to will be, so I'm going to cover all of them. So let's take a look at them one by one. So web services can be described in a life cycle. We start with planning, we then go to development, testing, deployment to production finally, and then we want to be monitoring and then reiterating on ourselves going back through planning. Planning is a pretty easy step. I generally like to just write a README or some notes on what I'm building along with like how the URIs work and the HTTP methods that I'm going to use for my service. There is also a language called API Blueprint, which you can use to describe like an API at HTTP level. And this is great for designing your API beforehand, before you go ahead and build it, because you can also prototype against it. On this slide, I've described an API action in my API I want to build called render. And it uses the HTTP method post, you can see at the top, and the path /render. And now what it does is it expects a request that passes application JSON with a payload similar to this. This is kind of an example. So this is a JSON object which has a template, which is just a string, and it says hello, curly brace, name, which is kind of like a variable substitution. And there is a context, and what it's expected to do is use this context to render the template. And I'll go more in detail about what templates are later, but this is just an example of an API. And when the API is given that example payload, it's expected to return a 200 response with exactly the rendered template, which would be hello, Kyle, with that context. So once we've figured what we're building and the rough design around it, we might want to go ahead and start building it. So finally to development. So one of the tools you probably find yourself using is the Swift Package Manager. It's the package manager that Apple released recently. It's not finally released yet, it's kind of a snapshot, so it's not fully there yet. But what it will do is it will download all your dependencies and build your web application. So it's available for Linux, and it's probably the only package manager at this time for Swift that is available on Linux. So currently there are 2 versions of open source Swift. There is Swift 2.2 and the unreleased version of 3, which is just a snapshot. So it's kind of like a moving target. Swift 3 doesn't have stable releases, and it won't have them for many months, probably not till, I guess, November or October time, by experience from Swift 2 and Swift 1 when they came out. And since Swift 3 is a moving target, it's kind of hard to develop against, because what works right now in one snapshot won't work in the future, and it might be questionable whether you want to deploy a web application using a language that doesn't have a final release. So you might want to consider using Swift 2, but unfortunately Swift 2 doesn't have like Foundation or the Swift Package Manager. So it kind of leaves you in a confused state. So it's kind of a bit early to decide which language to use right now, which version of the language. And since Swift is in early development, you'll find yourself wanting to switch versions to Swift. You also want to be installing like the latest release every week. So for this, I built a tool called SwiftEnv. It's basically a simple command line tool which allows you to manage Swift versions locally and also on your server, and it supports both Linux and OS 10. Now, what we can do once we've installed SwiftEnv itself is one line we can install a version of Swift. So I can say SwiftEnv install 2.2, and it will go ahead to Apple and say, is there a binary for this? Download it. If not, I'll build it manually. So it's great for easily installing Swift. And basically, it will just download the Swift toolchains on OS 10 and install them as they would be if you did it directly. So it's just convenience. And also on Linux, it just downloads like the table of the binary snapshot that Apple provide. Now, we can use SwiftEnv's local command to say that we want to use a certain version of Swift in a certain directory. So we can say SwiftEnv local this specific development snapshot, which was released. And then what it will do is it will create a .swift-version file in our directory, which contains that version. And it's advisable that you would commit this file so everyone downloading your project knows which explicit version of Swift or snapshot they should be using to build it or deploy it. It's great for ensuring everyone on your team is using the same version. SwiftEnv will automatically switch versions of Swift when you enter the directory with that file, which is really cool. So here we can see if we've done Swift version at the top, we're running version 2.2 of Swift. Now, if we jump into the directory called Stencil and then run Swift version, it's like SwiftEnv is automatically switched to our snapshot for 3.0 dev. So now we've seen some of those tools, let's take a deeper step. And let's look at some of the application frameworks you're going to use. So some of you might not know the difference between a web server and web framework. So the web server is the underlying component that passes the underlying request and hands it to the web framework or web application directly. You can use a web framework on top of a web server, which allows multiple conveniences, such as HTTP routing, which basically means you can route your paths of your website to certain functions and stuff like that. And I think it's very important to keep those two components clearly isolated. Lots of people coming into web servers in Swift are kind of building things that are both of these things at the same time. So I built my own web framework called Frank, after Frank Sinatra, the Sinatra Ruby framework. It's basically a domain-specific language for building web applications in Swift. Now, Frank is a real good example of the kind of type safety that Swift offers and what we can utilize in Swift. Frank offers type-safe URI and method routing, which not many other languages or frameworks have. So let's take a look at how that would work. So we can define a route using the HTTP method, which is basically a function in Swift, get. And we can pass it 3 strings as arguments, users, Kyle, followers. And then we have this closure, which is handled for that request. Now, what happens here is that these 3 arguments are translated to a path. So /users/Kyle/followers would be the path. And every time someone requests that URL on your server, this callback will be run. And you can return a response. We can pass pass a path component of asterisk, or like a wildcard, to state that this is a variable path. So a component slash user slash something will be handled in this case. This asterisk allows you to annotate exactly where variables are and map them to your closure. So Frank allows you to use any number of wildcards, so you can match variables in any part of your path. And the wildcards map directly to the parameters, and they're like translated to the type you asked for, so string in this case. You can also use any type that conforms to a protocol called parameter convertible. So this allows you to build your own enum. So for example, or even make a type such as integer, double, date, translate from a path component to your parameter. So for example, we might have a parameter in our URL which can either be open or closed. So it's kind of like a status or a state. For this, we can describe it in an enum in Swift. So we have an enum called status. It has two cases, open and closed. How would we go about mapping the path to that? So let's take a look. We can make our enum convert to parameter convertible, and we just need to add an init method, which is an optional, and it takes a parameter parser. So what you can do is you can like pop or shift parameters from the parser. So for example, we're going to shift the first one, and we're going to say, is it open or is it closed? Return the correct enum value, or return nil, saying this doesn't match our parameter, so it should get a 404 eventually, or another route should handle it. So now we can use our custom status type in the URI as shown here. So we say /issues/asterisk, and we say that the type is status. So it's automatically going to translate that to status. And if that's not possible, this might return in a 404 to the user, or our enclosure, which is just going to return a string which says issues using status and the given status. So the previous examples offer full type safety in the parameters. In other languages like Ruby and Python, you usually don't get this kind of safety. So traditional frameworks usually work like this, like I've shown on this slide. I've kind of translated it to Swift just so you're more familiar with the syntax. But basically, you pass in a single string which represents the whole URI. So it's not able to know where things are. So we've said /users /colon username for our URI instead of how we did it previously. And this means that the web framework can't translate those arguments directly into your parameters. They need to pass some kind of like dictionary called params, which means you have to pull it out yourself. Although we know that the username will always be in our params in this case, we can explicitly unwrap it. But with Swift, we can do so much better. We can utilize like Swift's type safety in type system to enforce this at compile time. So if we made a typo during refactoring, this wouldn't compile. If you made a mistake in one of the strings, it wouldn't compile. So outside of Frank, there are also other web frameworks. So I mentioned that IPM seems to be getting into this business of Swift on the server. So they've released their own web framework called Tutura. And let's take a quick look at how you'd use that. So a small example here of using it is we can handle /users /wildcard similar to the non-tape safe example I showed you earlier. And this would return hello in the name that it was given. Now, unfortunately, this passes a dictionary as URI parameters, and I think we can do so much better in Swift. This is just taking like existing ideas from other languages and just porting them to Swift. I think instead we should be thinking more about how we can do things better in Swift while embracing the type-safe language. So we've looked at web frameworks. Now let's take a look at web applications. So you're going to need a web server for this, and we have a couple of options. So there's one that I've built called Carousel. It's a web server that uses what's called a pre-fork worker model. Now this means that the server creates sub-processes up front to handle all the requests, which means that if your code was to crash, it would automatically be recreated like as a new process without losing additional requests. The pre-fork worker model leaves load balancing between workers directly down to the operating system kernel. So this means that requests will never pile up behind a busy worker, like one that's already handling a request. It will just go to a different worker. So by design, Carousel exposes an API where you can build your own event loops. So by default, it uses a synchronous one, but you are free to build your own and integrate them to Carousel really easily via the API, which allows you to experiment with different technologies, because we don't know what is best for Swift yet. So you can experiment with Grand Dispatch or a libuv, which is a traditional framework for eventing. Now, unfortunately, we are seeing multiple web servers emerging with no consistency in their API. So there is no standard for building HTTP servers in Swift. There's like no standard interface. I think we should be learning from other programming language mistakes and building standard interfaces so all web applications communicate to web servers in the same way. We don't want to tightly couple our web frameworks and web applications specific HTTP servers. No one server is going to fit every use case. Now, depending on your performance needs, you might want to build your application in a specific way, and you might need to use a certain web server which like does different eventing or such as that. So without a standard, it's very hard to easily switch because you're really tightly coupled to the underlying web server. So to rectify this problem, I've created kind of a specification called Nest. Now, Nest is pretty simple by design. It basically just defines a couple of protocols, request type and response type, and it expects you to register a callback, in this example called application, which just takes the request type. So since it's a protocol, it means you can implement your own, and it returns a response type, which of course you can implement again because it's a protocol. So the web application I showed earlier called Frank uses Nest, and so does Curacao. And there are also other web servers and web applications using using Nest even. And to get Nest out as early as possible, I released it like as soon as I got some prototype. So it's quite early, and I pull it up with this Nest enhancement proposal. So basically, you can like propose changes to the specification, because obviously it's probably not perfect. There could definitely be things we could improve, like with delicate consideration. So depending on what web service you're building, you might be interested in using a template language. A template language is a language, like a domain-specific language inside that you can use to like do kind of like looping and variable substitution. So many templating languages allow you to just write templates in HTML with like certain keywords. There are different types. In some languages, it's quite common to directly embed Ruby into your template, such as in Ruby's ERB, and other languages have something similar like PHP. I built my own template language called Stencil way before Swift was open source because I wanted to use it on mobile applications. So this is a great use of something I've built way before Swift was even considered on server and been able to utilize on the server. Now, Stencil separates presentation logic from your application logic, and it doesn't let you embed Swift directly by design. Stencil provides you with simple operations such as looping and branching, which allow you to write presentation logic. It's limited to presentation logic only. It's not intended to write direct, like complicated logic. It's not the user of a Stencil template isn't the same user as a developer. It's a like web designer or such. So as example, we can use Stencil to build a HTML list. So if you're not familiar with syntax, the top is a heading in HTML. And then we've said we want an unordered list with all of the users. So what we're doing is we're just using a for loop with the Stencil syntax, which is for user in users. And then inside that, we're just going to print the user wrapped in HTML tags. And this will just loop over them and print the users that were given to the template. So moving on. When building a web application, you might want to talk about persistence. In most languages, there are available ORMs, or object relation mappers. Unfortunately, there are none written for Swift at the moment. And building an ORM in Swift is kind of tricky because it's a very type-safe language and it's hard to do without dynamism that you might need to do it. Ideally, an ORM in Swift would allow you to do type-safe querying of models in your database and automatically map the values in the database to your model structures. Now, an example shown here is actually possible with Core Data. I built a library a while back which it unfortunately requires some level of code generation to be able to do this type-safe querying. And so since this is Core Data, we can't use it on the web server anyway. So there are some options available for the web, but quite not as elegant. So there's definitely an opportunity for someone to build an ORM if they can figure out how to do it right. So what do we have as options? So one popular one is Redis. Lots of web applications use this. It's a data structure store, and it can be used as a database. There is a native Swift library called Redbird, which you can use. And here's a quick example. So here we've created a client. And what we've done is we've said we want to set the name parameters, like key value, to MCE. And then later we can go and get the name from the data store. Just by excellent query. It's quite raw and low level, this. There are also more traditional SQL databases such as Postgres. Now, Postgres is one of the most popular open source SQL databases at the moment. Unfortunately, there are no native Swift libraries to use it, but there are some that wrap the C library that you can use for Postgres. So here's a little bit of code we can use to both connect to like our Postgres server. And then what we can do is we can say we want to execute this query. We want to get all of the users from our user table. And then we're going to like get the username out of it. And there's like no type safety or whatsoever. We have to, well, there is type safety because it's Swift, but we need to deal with that ourselves, which is kind of inelegant. So the next stage in building a web application is testing. You might want to do TDD or test-driven development. You'll probably also want to do some manual testing if it's your first time, like actual hitting it with a browser or curl, like a command line HTTP client. So what can we have for testing? So there are a couple of ways. There's Spectre, which is a behavior-driven development framework I built, and it's a test runner for Swift. So it's more than like a testing framework, it's also a test runner. Now using the BDD style, you can write straightforward tests in Swift. So here these work on Linux, I might want to add. Here we've described a person, simply just by calling a function called describe, passing a closure. And then we can say it has a name, and we can use the error handling in Swift by just saying expect person name equals Kyle. This is done by some like operator overloading to provide this kind of syntax. And you can build your tests as a command line tool and then just run them, and then you get this output directly. You may also use XCTest. It's the traditional testing framework I'm sure you're all familiar with, if you're doing iOS development at least. And you can write your test just as you normally would. You can extend XCTest case and add test functions. But unfortunately, since on Swift, there isn't an Objective-C runtime. So there isn't the runtime that allows introspection that's already used by XCTest on Apple's platforms. So what you have to do is you have to make your class conform to XCTest case provider. And to do this, you need to add a function called, or a property called all tests. And what this does is it returns an array of all of the test names. And then what you need to do is you need to call XCTest main to run XCTest. And you need to pass it your class. So this is kind of problematic since you need to remember to add all your tests here, else they won't actually be run. They'll just be there. There's actually cases in like Swift Package Manager's own test where there wasn't being run because they forgot to do it in some cases. So it's kind of problematic and hard to remember. We can also use HTTP testing tools. So there is like wide range of tools that are already available that are agnostic to any language. So for example, Dread is a great tool that allows you to take your API description. So earlier I showed like a description called API Blueprint, which described my API. And what I can do is I can use Dread to take that description and the examples in it and go make those requests to my real HTTP server, like my real implementation, and verify that those were correct and the server implements them correctly. If you're familiar with Travis CI, it's a continuous integration service that allows you to run automated tests. So using SwiftEnv, you can easily use and install Swift on both Linux and OS X on their systems. And you can follow the instructions on that guide to do it. And it will let you just set tests using snapshots versions of Swift on Linux. So we finally designed, built, and tested our web application, hopefully. Now let's explore how we can deploy it. So when it comes to deployment, there are various options and many ways you can do it. So I think the simplest option is Heroku, because you don't have to worry about maintaining servers. You can simply push your code to them and they will build it and run it. You don't worry about anything else. They take care of it all. And they easily allow you to scale your web application. So you can basically just say, I want to scale my application from 1 instance to like 100. And right there, and then you have 100 instances your server running. So you can handle additional traffic really easily without any additional effort. So to deploy to Heroku, we will need to use the Swift Package Manager because that's how the Heroku build pack, which is the thing that builds your code together and runs it, works. So we need to have a package.swift, which basically says the name of the package and also any dependencies we might want to use. So in this example, I'm going to use Frank, the framework I showed earlier. So for this example, we're using Frank, and we're building a command line tool that can be used to run our server. Hence, we've put the source in the sources directory called in a file name called main.swift. So if we do this, what Swift build will do is it will build our thing as a command line tool over the same name as our project, our package. So our example code here is going to return a hello world if you recall do a get request to the root of the API. If you do get request to slash something, because the asterisk, it'll pull out that username and just say hello username. So our example will return these as such, so you can pass in slash MCE and it would say hello MCE back. So we can specify the version of Swift we're using in the .swift version, which means that when we deploy or push our code to get Heroku, what it will do is it will download the correct version of Swift and run it. I think it's very important to include this file because you don't want next snapshot or a new version of Swift to just be switched up on you and it'll be changed. So it's a good idea to ensure that it's the same version that you initially used to develop it. So we can run the example locally. So those two files is all we need to build that example. We can Swift build to build it, and then it will download the dependencies and build that command line tool. And then the next line here, we've just run the command line tool called hello, which is what it built. And as soon as it did that, we're now hosting a HTTP server, which is that example locally. Now, Heroku will need instructions on how to run your server, because it can be changing depending on, you can change different arguments to the command line tool, or your command line tool name can change, etc. So you'll need to add instructions. And to do this, you create a file called proc file, which is just a simple format. It says web, which is the type of worker, so it's a web server. And then just the command to run, which is just hello. And to do this, you just specify that. Now, once we've finished, we can commit all of those changes to our Git repository, and then we can create a Heroku app with our command line tool. Now, to do this, we just say Heroku create. We pass in -- build pack. Now, the build pack is kind of the code that you use to build your code together and run it on Heroku. So I've created a build pack, which you can find on the URL, which basically will do everything for Swift for you. And then once you've got an application created, it will add a git remote, so then you can just git push your code. So then you can git push Heroku master, which will push your master branch to Heroku. And what it will do is then the build pack will take over during the push stage, and it will build your code together and create an image of it that it can just run on the server. So once we've done that, Heroku will just deploy it. So 2 steps. Once we already have an existing application, create and push, and that's it. Once it's deployed, we can go ahead and test it directly on Heroku. So here I'm using curl, a command line HTTP client. You can see requesting the root of the service returns hello world as we expected. And you can see that if we do request / MCE 2016, it would return hello MCE 2016. Another option we have to deploy our Swift code is IBM's Bluemix, so the platform I mentioned earlier. It works very similar to Heroku. In fact, it uses a platform underneath called Cloud Foundry, which has a swimless Swift build pack. It works exactly the same as I showed before because it's actually a fork of the Heroku build pack I built. So you can use that in the same way. So you can also deploy it yourself and manually manage it if you really want. And it may be cheaper to do this if you're actually doing it in production. So you can manually install Swift, perhaps via SwiftEnv on your server, and then just run Swift build to build your code, and then run the command line tool. There are also Docker images available for those interested in Docker, which you can easily find. So once you've deployed your web application, you probably want to be worrying about monitoring it. What happens if some problem arises? Would you know if you started returning 500 errors and the user had some problem? So there's a few options available, but there's not quite the options you'd have in other languages because it's quite new, Swift's a new language. And I think the easiest way to do it is with logging. So what you can do is simply log events to the standard out of your application. So you can just log something, and then you can use services on top of this to amalgamate the events into an alert or a graph. So for example, we could use print function in Swift to just print this error. So it's error, there's a keyword we can use for searching, and then the error that happened. So Papertrail is one of these services where you can use for logging. So it allows you to configure webhooks to do alerts based on certain logged events, which is really handy because it's very flexible. So with one click, it's possible to add Papertrail to Heroku and configure it all together. And then what it would do is any output of your Swift command line web application would throw it up to Papertrail in the logs. So for example, I could use Papertrail to email me when certain errors, certain logs meet the search criteria, which is traceback. So if I'm using Swift in web, there's an error raised called traceback. It will go directly as an email to me. You can also configure Papertrail in conjunction with like res incident like systems like PagerDuty, which are quite popularly used in web applications. There are also statistic services that you can integrate to Papertrail itself. There's one called StatHat, which I've used. There's also Datadog, and you can use these to configure like based on certain search terms. So basically what I've done is my application logs, like every time a push notification is sent, it just says this was successful, basically. And what it does is a Papertrail has a query saying, like matching that like line, and then it will send these to StatHub, and what they'll do is they'll build actual graphs based on my push notification traffic, which is kind of handy to visualize things. So I can see this graph shows the amount of push notifications that my service handles over time. So we've seen where we are. What's next? Swift 3 is going to bring various language changes, but it'll also be the first release of Swift to actually finally have the Swift package manager and foundation on Linux, which is complete. Swift 3 will bring a stable API to the language, which is going to be quite important going forward, I think. And over time, as we see the language mature, we'll also see the availability of libraries. They're quite sparse at the moment. There's only a select few, mostly the ones I've built, and there's a couple of others interested in it. So there's like great opportunity to build libraries at the moment for Swift Web, like logging, monitoring, such, and also a norm. I really want to see a norm. So what have we covered today? We've seen why you might want to develop a web application in Swift, and we've also seen how you can design, develop, and deploy your Swift web applications. So I've published the slides on the internet, and you can find them at this link. And I want to point out that everywhere there's an underline on a heading, it's actually a hyperlink, so you can find additional resources everywhere. That's it, so thank you.
Thank you, Kyle. It was great to having you here. And I've seen that you've created this Nest specification protocol. Yep. Yeah. Have you heard about WSGI protocol specification in the Python? This is very similar like this one. So for those who don't know, this is like a specification to building a web application on top of it, and then you can have multiple web servers and frameworks to coexist together. So you mentioned about API blueprint. Does your tool stack support this?
So API blueprint is kind of language agnostic. So basically you just describe your API in like kind of a markdown-like syntax. And then, for example, the tool I mentioned called Dread is written in JavaScript, and it can test against that. So it's like you can develop your application in any language and use these tools, some of these tools. That's what's great is we can utilize existing tools that people have used for web development, because quite a lot of them are tied to your programming language.
It's very similar to RAML, raml.org. It's very similar to this one. Okay, do we have questions for our guest? There's a lot of questions. I suppose you were the first one.
Hi, Kyle. Thanks for your talk. Very interesting. I have a question regarding Frank framework.
Yep.
From the slides, I've got the impression it's a Swift 2.2. So is that correct? And if it is correct, how that compares in terms of performance and stability to Kitura, which is currently on a Swift 3 development branch?
So currently, Frank supports like the stable version of Swift 2.2 and 2.21. It also supports some of the snapshots for Swift 3. It doesn't support the last two because they changed some languages, like language rules that I haven't been able to refactor into the application. But my intention is to make it support both very soon when I have like some free time. Ideally, all the tools can run on both the 3.0 snapshots and 2.2. Because you can use conditionals in your code, like hash if Swift version is 2.2, do this thing, else do that. So it's quite easy to develop frameworks that work on both.
The next question? Yeah.
Hi. I've got a question about asterisk. How do you actually pass it? I mean, how does it work?
So basically, what there is there's various versions of the get function with different amount of parameters. And what it does is the asterisk is basically just a function. So asterisk is the multiplication function, right? it basically just uses that and says that the second parameter in this is a function which takes an int and takes another int and returns an int, which is then multiplied together. What's great is that this can be optimized out. So it's just like an annotation because Swift doesn't kind of allow us to do this in any other way. But what's great is we can utilize this to get complete type safety in URI handling.
That's kind of clever, I suppose.
Yeah.
There was one more question. Yep.
So, thank you very much. Very interesting. Do you have any comments about how to try this stuff with Raspberry Pi?
So unfortunately, I don't think there's any Swift like binaries available. So you'll be down to building Swift itself on the Raspberry Pi, which I'm not sure if possible. So what you have to do is you have to cross-compile it from a computer which is powerful enough to build Swift. Fortunately, to build Swift, there's very high memory constraints. You need 16 gigabyte of memory to be able to build Swift itself. So you're not going to have that on a Raspberry Pi. So what you'll need to do is, I'm not sure how it's going to be done, but you'll have to perhaps ask in the Swift mailing list. I think that'd be pretty helpful. You can ask like how you'd be able to cross-compile it to a Raspberry Pi. Once you've done that, you should be able to use all of these application frameworks just as you normally would. It's just getting the language there is the hardest part.
A question you I have about the web server piece of it, and you implied that there are several people writing web servers and stuff. Why does everybody want to write a web server? Why don't we use existing web servers? Is nobody writing like a module for Apache or Nginx or something like that?
I don't think anyone's done that. So what the idea is behind like the carousel is you sit that behind Apache, behind Nginx is like the proxy and server, and then your workers would be in Swift directly. I think lots of people are coming from different backgrounds, so a lot of people doing these web servers don't actually have experience in the web in other languages. So that means they're doing it in different ways because they're not familiar with how it's already done.